Hello, amazing students, amazing people, and all the lovers of chemistry out there. I'm super excited to be here with you once again on another episode where we treat a practice question balancing a redox equation. It's been an interesting series thus far where we've seen different questions solved, different aspects of the comprehensive topic. And today we want to treat this equation and balance it in a basic medium. My name is David, and all I do here is to take the mystery out of chemistry so chemi can make history. So I'd like you to sit back, relax, and enjoy every bit of today's show because it's going to be a blast throughout. So let's get into what we have today. We have been asked to balance this redox reaction in the basic medium. So let's take it step by step. You've seen the steps on how to balance a redox reaction in a basic medium. So let's take it one after the other. So the first thing that's required of us to do is to split this reaction into the two halves, the oxidation and the reduction half. So doing that, we have the first equation, which is NH₃ yielding N₂H₄. And then we have ClO minus yielding Cl minus. Now that we've split this equation into two, let's find out which one is the oxidation half and which one is the reduction half. For the first half that we have this NH3 giving us N₂H₄. Let's go ahead and calculate the oxidation number of nitrogen in both compounds. That will tell us if what we're dealing with is oxidation or reduction. So to calculate the oxidation number of nitrogen here, since we do not know what it is, let's just name it X plus. Now we have hydrogen here, and the oxidation number of hydrogen in compounds is always +1, multiplied by how many atoms of hydrogen do we have? We have 3. So everything now will be equal to the overall charge here, and there is no charge, so the charge is 0. So everything here becomes 0. So therefore, we have X plus 1 times 3 gives us 3. This is equal to 0. So X plus 3 is equal to 0. And then finally, we have X is equal to minus 3. So the oxidation number of nitrogen in this compound is minus 3. Now let's find out the oxidation number of nitrogen in this other compound. So now we have the oxidation number of nitrogen, which is X, since we don't know what it is. And we have 2 atoms of nitrogen, so that becomes X times 2 plus, we have hydrogen over here, and the oxidation number of hydrogen is +1, times, how many atoms of hydrogen do we have? We have 4. Everything is equal to the overall charge, which is 0. Now 2 multiplied by X gives us 2X plus 1 multiplied by 4 gives us 4. This is equal to 0. So now we have 2x plus 4 is equal to 0. Now we have 2x is equal to minus 4. Because when we take this 4 to the other side, it becomes minus 4. So now we have minus 4 over 2 so that we can get this x. 2 cancels 2. 2 into minus 4. X is now equal to minus 2. So we have x going from minus 3 all the way to minus 2. Now, when something goes from minus 3 to minus 2, do we say it has increased or it has decreased? Of course, we say it has increased. Had it been, it had been maybe from, let's say, +3 to +2, we would have said it had decreased because of this plus over here. But in this case, it is a minus. So that's why we say it has increased. And when it has increased, we said this is the oxidation half. Because when oxidation number increases, we say oxidation has taken place. Now, let's find out for the other equation. So for the other equation, we have ClO minus yielding Cl minus. Now, let's name the oxidation number of chlorine to be X in this equation. So we have X plus Oxygen over here has the oxidation number of -2. So this is equal to the overall charge, which in this case is -1. So we have x minus 2 equal to -1. Therefore, we have x equal to -1 plus 2. X is equal to +1. So the oxidation number of chlorine in this molecule here is +1. Now, on the other hand, however, we have Cl minus. The oxidation number of chlorine in this on the right hand side is simply equal to the overall charge here, because it is the only atom there which is -1. So on the left hand side we have a charge of +1, and on the right hand side we have a charge of -1. When it goes from +1 to -1, does it increase, or has it increased, or has it reduced? Of course it has reduced. So that tells us that this is our reduction half. Now that we have identified the oxidation half and the reduction half, the next rule says we are to balance all the other atoms apart from oxygen and hydrogen. So let's do that. All right, now, so in the first equation, we have NH3 yielding N₂H₄. Apart from oxygen and hydrogen, do we have any other atom in this equation? Yes, nitrogen. Over here, we have two atoms of nitrogen because of this subscript of 2 here. And over here, we have nitrogen, which is just one atom. So we have one atom of nitrogen on the left side, and we have two atoms of nitrogen on the right hand side, which tells us that we need to put a coefficient of 2 here in order to balance nitrogen. So we have balanced nitrogen now. For the other equation, we have ClO minus giving us Cl minus. Apart from oxygen and hydrogen, are there any other atoms? Yes, we have chlorine over here and chlorine over here. And in this case, chlorine is balanced, one atom on both sides. So we do not need to alter anything. The next step now says balance oxygen atoms using H2O and balance hydrogen atoms using hydrogen ions or H plus. So let's do it for the first equation. We have 2NH3 giving us N2H4. So the first step says balance oxygen atoms using H2O. Do we have any oxygen atom in this equation? No, so we do not need to add any molecules of water. Do we have any hydrogen atoms in this equation? Yes. On this left hand side, you can see there is a 3, a subscript of 3, which indicates that hydrogen has 3 atoms, and there is a coefficient of 2, which indicates 2 times 3. We have 6 atoms of hydrogen on the left hand side. On the right hand side, however, we have just 4 atoms of hydrogen. So that tells us that we need an extra 2 atoms of hydrogen or H plus ions in order to balance hydrogen on the other side. So what do? We simply add H plus 2H plus ions. Did you see how this was done? We simply add 2H plus ions. Now for the other equation, we have ClO minus giving us Cl minus. Now there is one oxygen atom over here, which means we need to add 1 molecule of water to balance oxygen. Now we just introduced some hydrogen atoms to the right hand side when we added a water molecule. How many hydrogen atoms? 2, because of this subscript of 2 over here. So that tells us that we need to add 2 hydrogen ions to the other side to balance it. So now what we have as our 2 new equations will now be NH3 or 2NH3 yielding N2H4 plus 2H plus, and then we have ClO minus plus 2H plus yielding Cl minus plus H2O. I'm sure you've seen how this was done. Now, the next rule says after you have balanced all the other atoms with water and hydrogen ions, balance the charges using electrons. So let's see how to do that now. Now, at this point, what we want to do is to balance the charges by adding electrons. How do we do that? All right, I'll show you how by writing the first equation first. We have 2NH3 yielding N2H4 plus 2H plus. Now, what we want to do at this point is to find out the total charge on the left-hand side and find out the total charge on the right-hand side. Then we will add a sufficient number of electrons to the side that is more positive so that we can balance out the charges. Here is what I mean. On this left-hand side, you can see it is basically neutral. There are no plus or minus signs. So the total charge on the left-hand side is 0. On the right-hand side, however, you can see this molecule. It is not charged, no plus or minus sign. So its charge is 0 plus. Over here, you can see there is a charge, which is plus, and it indicates a charge of +1. And then there are 2 atoms of hydrogen ions that own that +1 charge. So it becomes +1 times 2. So the total charge on the right-hand side becomes 0 plus 2, which is equal to +2. So on the left-hand side, we have a charge of 0. On the right-hand side, we have a charge of +2. Now, we need to add a sufficient number of electrons to the side that is more positive so that the charges on both sides can balance. So how many electrons do we need to add to +2 to make it to be equal to 0? We need to add 2 electrons. Because basically it's just like saying +2 minus 2. That gives us 0. So now we've done that for the first equation. We've balanced the charges. Writing that out now becomes 2NH3 giving us N2H4 plus 2H plus 2E minus. Now, coming to the second equation, we have ClO minus plus 2H plus giving us Cl minus plus H2O. Now, on the left-hand side, let's check out the total charge there. You can see there is a minus sign here, which indicates a charge of -1, plus. Over here, you can see there is a plus sign, which indicates a charge of +1. And then there are 2 atoms of hydrogen that own that plus sign. So it becomes +1 times 2. So we have -1 plus 2, which is equal to +1. So the total charge here is +1. On the right-hand side, however, you can see there is a minus sign here, which indicates a charge of -1. And over here, this molecule is neutral, so its charge is 0. So we have +1, -1 plus 0. So on the left-hand side, we have a charge of +1. On the right-hand side, we have a charge of -1. Which side is more positive? Of course, the left-hand side. Now, how many electrons do we need to add to the left-hand side to make this side to be equal to this place? We need to add 2 electrons. 2 electrons to make my +1 to be equal to -1. It's just like saying +1 minus 2. It will be equal to -1. So now the final equation or the new equations now become, let's write the first one out. We have 2NH3 yielding N2H4 plus 2H plus 2E minus. And then the second equation now becomes ClO minus plus 2H plus yielding Cl minus plus H2O. Now remember, we've not added our electrons to this equation. So let's go ahead and add our electron. We have ClO minus plus 2H plus 2E minus yielding Cl minus plus H2O. So now the next step to do is to make sure that the electrons are equal in both equations. So let's do that very quickly. Now at this junction, we want to make sure that the electrons are equal in both half reactions. So on the left hand side or on the first equation, we have 2 electrons. On the right hand side, we also have two electrons. So there is no need to take any step to make electrons equal because they are already equal by default, which means these two electrons over here can cancel these two electrons over here. So when we do that, we end up with this new set of equations. Now we have 2NH3 yielding N2H4 plus 2H plus, and then the other equation follows suit, ClO minus plus 2H plus yielding Cl minus plus H2O. At this point now, we can combine both equations together. Everything on the left hand side on the first equation goes with everything on the left hand side on the second equation. The same thing goes with the right hand sides of both equations. So let's add them together. We have 2NH3 plus ClO minus plus 2H plus yielding N2H4 plus 2H plus Cl minus plus H2O. Now, at this point, we need to check before we proceed any further to do anything. We need to do a little bit of math. If there are any similar atoms or molecules that exist on both sides, we need to cancel them out. What do I mean? For example, you can see on this left hand side we have H plus molecules or ions, and over here we also have H plus ions. So 2H plus ions on the right hand side and 2H plus ions on the left hand side. So these two can cancel themselves out. It's just like saying 2 minus 2, which gives 0. So now, are there any other atoms or ions that are the same on both sides? No. So we can come and write our next equation. We have 2NH3 plus ClO minus, giving us N2H4 plus Cl minus plus H2O. Now, at this point, the final rule says that if there are any H plus ions in the equations, add an equal number of OH minus to both sides in order to neutralize these H plus ions, because we are balancing in basic medium and we do not want this guy to be remaining. So in this final equation, do we have any H plus ions? No. So therefore, this becomes our final equation. This becomes our final equation, our final balanced equation. So our final balanced equation is this over here. So now that we have our final equation, let's just do a final subsidiary check. We need to check if all the atoms on both sides are equal and if the charges are equal as well. So for the first element, we have nitrogen. On the left hand side, how many atoms of nitrogen do we have? We have 2 because of this coefficient of 2 over here. So on the left hand side, we have 2. On the right hand side, however, we also have 2. So 2, 2 makes nitrogen balanced. The next atom is hydrogen. How many atoms of hydrogen do we have on the left hand side? You can see there's a coefficient of 3 here, which signifies that hydrogen has 3 atoms, and then there is a coefficient of 2 here. This is actually a subscript, not a coefficient. There's a subscript of 3 here, and we've indicated it. And then there's a coefficient of 2 here, which indicates 3 times 2, which is equal to 6. On the left-hand side, we have 6 atoms of hydrogen. On the right-hand side, how many do we have? We have 4 over here, 4 atoms of hydrogen, which is 4 plus. Over here in this H2, we have 2 atoms of hydrogen. 4 plus 2, which gives us 6. Hydrogen is also balanced. Left side 6, right side 6. For chlorine, how many atoms of chlorine do we have on the left hand side? We have 1 atom of chlorine here, and we have 1 atom of chlorine on the right hand side. 1 makes chlorine to be balanced as well. And then finally, we have oxygen. On the left hand side, how many atoms of oxygen do we have? We have just 1. And then on the right hand side as well, we have just one makes oxygen to be balanced as well. So we've seen that the atoms are balanced. Let's check out the charges on both sides to see if they are also balanced as well. So we have two NH3 plus ClO minus giving us N2H4 plus Cl minus plus H2O. On the left hand side now, where are the charges that are present? We have a minus sign over here which indicates a charge of -1. There are no other charges because this is neutral. There are no plus or minus signs hanging over it. On the right hand side, however, we see that this is also neutral, no charge, but over here we have a minus sign which indicates a charge of -1, and this is also neutral, no charge. So left side -1, right side -1. So this equation is fully balanced in the basic medium. I want to say a very big thank you for staying with me up until the end of this equation we just balanced. If you're interested in chemistry, once again, I'm saying to you, please do well to subscribe to this video or to this channel rather. Like this video and share to as many as are interested in learning about chemistry. Till I come your way next time, my name is David, and all I do here is to take the mystery out of chemistry so chemi can make history. See you in the next video.